All right, guys, we're recording. So, what we're talking about today is exponents. So let me do this for just a minute. When we start talking about some of this stuff, we are using materials that we have used in the past. Like this Unit 4 book that we have here is the book that we had used the last 3 years. We've changed it a little bit each year. This year we tried to change it a little bit more so that we had a little bit more for us to kind of work with. But I guess the question that I have for you guys is the following: if you are looking at this stuff, how many of you use this QR code ever? That's up on the upper right hand corner of some of our notes. If anybody has ever used one of those QR codes, say I have. If not, say no. So AZ's got a never, and I appreciate that. Okay. Got an I have. All right, that's fine. I want to give you kind of a heads up as to what that's about. So these guys up here, we specifically use a curriculum that has some access to some different resources that are out there, and one of them is that if you click on that, it gives you a video going through the notes as we talk about them. And there's a guy that goes through and talks about these. Now he is going through the original notes without any changes. So like we have cut some things out, we have changed some things the way they're here. We're using Word documents and changing them to Google documents, and we're doing a lot of stuff. That QR code will definitely give you good information, and it's going to be the sort of stuff that you need, but it's not necessarily everything that you're going to want. So here's what I want to make sure that you know. When you're doing this, if you want to click on that, that's great. There are some times when they don't have them up in the corner. If it's not there, it's because we've completely rewritten the section and there isn't even a part of it that's good. So just know you can use that if you'd like, but you don't have to, and that's completely and totally fine. I will ask this: how many of you guys remember anything about integers that we did sort of in the first semester? And really, we've done this all the way since at least Algebra 1, but how many of you guys remember anything about integers? I got a kinda. Okay. A couple kindos. Um, Most of what we're going to be doing here is just a review of some of the things that we've done in the past, because our whole unit here for chapter 4 is on exponential functions and on their inverse, which is called a logarithmic function. And this is a long chapter. It's going to take us a little while. The first portion of this is all about exponentials. So we're going to spend a whole lot of time talking about exponents, working with how these expressions work, and making sure we kind of understand what's happening. And so we did a little bit of a review of this material first semester, but we wanted to make sure that we had a chance to kind of look at this in a way that is going to be memorable, but at the same time, give you a little bit of an opportunity to sort of see how it works and ask some questions if you're not 100% sure. Because, without looking at the notes yet, what we have down here is a bunch of different exponents, both starting at a number here, 3, that's here in the shadows, all the way down to a -3, and sort of figuring out what happens as we move down in a direction here, going in a negative exponent, going up towards positives, and what happens when we have a 0. And so we're going to talk about that for a minute, but let's start at the most basic. If I have a 4 to the 3rd power, what does that mean? Like, what does that mean that I'm going to do if I'm going to write that out and expand it? How does that look? What do I do with that? Can somebody tell me? 4 to the 3rd power. What does that mean I'm doing? Is that 4 times 3? Does that give me 12? All right. Oscar's got us. It's 4 times 4 times 4. Exponents are just repeated multiplication. That number up at the top tells you how many times you're multiplying, right? So it's 4 to the 3rd power. If we're going to expand it, it's just 4 times 4 times 4. So however many times we have here, that's how many times we write it. So understand, really, exponents are really there to help us conserve the amount of space that we're using when we're writing these things. Because what you'll notice as we do more and more work is that repeated multiplication happens kind of a lot. And so the more that we can write some of these things in such a way that they are written up as exponents, the less space this takes. Now, 3 of them is not that much to deal with. But when you start to get to like 4 to the 15th power, man, I ain't going to write 15 of these. That would suck. So that number there sort of represents how many we have. And the nice thing is that when you start to work with numbers like this, you realize that there are rules that we can follow that involve how these interact with each other when we're looking at things with the same base, when we're looking at things with different bases, and what we can do with those exponents to shortcut the amount of work that we would have to do. So a lot of our laws of exponents are there so we don't have to write it all the way out, figure out how many we have, count everything up, rewrite it again. It's shortcuts to be able to take a little bit more time. And so in both of these cases, we can evaluate what this is. 4 to the third power, or 4 times 4 times 4 is just 64. So we can get a final answer. But most of what we're going to be doing here is not getting to those, but getting to the back and forth between how do we take repeated multiplication and write it up as exponents? How do we take an exponent and expand it to be able to write things as repeated multiplication? And then what do these numbers work at? Now, what we're trying to do with this exercise 1 is to sort of recognize how that pattern goes. And what I do want you to see is that this is written out in such a way that it's kind of like, and I don't, guys, I honestly, we're coming up on like the year anniversary of us being in the lockdown sort of at home stuff, and figuring out what we taught before and what we didn't, and what things worked before and what didn't. Like, my brain doesn't really hold on to that very well. I know in the past that you have learned about sequences of numbers and sort of trying to figure out, based upon how numbers grow, what those patterns are, how we can expand that pattern, what it looks like. I believe back in Algebra 1, you were asked to do some things with sequences, with how those things grow, and if I was going to be making this list of numbers to the left and to the right, what that would look like. And that's lovely. That's kind of what we're doing here. When we're looking at exponents, since this is just repeated multiplication, what essentially we're doing every time we go to the right is we're adding another times 3. So like we've got here, this is 3. 3 times 3 gives me 9. 9 times 3, what does that give me? What is 9 times 3, everybody? Anybody got that number off the top of your head? 9 times 3? 27. Thanks. So what we're looking at here as I go to the right is I'm adding a number, another 3 there. So 3 to the first power, there's 1 of them. This has got 2 of them. This has got 3 of them. Now, this is what we're super familiar with, right? So if I'm multiplying by 3 as I go this way, what would that mean I did if I went that way? If I'm going to the left on this pattern, what am I going to be doing as I go in that direction? Because it's times 3 there. It was 3 to the 4th. Like, I'll even write that one because I know what it is. If I got 3 to the 4th power, I'm multiplying times 3 again. That's going to give me 81. So you guys got this. If it's multiplying by 3 this way, what will the opposite of that multiplication be? And Kevin, you're really close. The one thing is, since we're multiplying and by subtract, it's not going to take enough of it off. What do I do if I'm multiplying to the right? What am I doing as I go to the left? What do you think? Greg, you're right. It's going to be dividing. So when I do this, if I go this way to write them, that's the way the pattern works. Now, I'm going to write those out in this line here. And then once I'm done with that, I want to sort of talk a little bit about how this is going to work. Because right now, 3 divided by 3 this way is going to give us a 1. All right? And that's completely fine. And it's still, the pattern still holds. 1 times 3 gets me here. Now, if I go this way, can anybody tell me, if I do 1 divided by 3, do you guys know what I get? Because that's what this would be over here. What is 1 divided by 3 equal to? Now, 3 divided by 1 is that. If I'm doing 1 divided by 3, oh no, people are losing the internet. Oh, guys, I'm sorry. Okay, so here's what I want to ask. Does anybody know what 1 divided by 3 is? Like, if I use a calculator and I do 1 divided by 3, I'm not going to get 3 because, Greg, what you did is you flipped them. You did 3 divided by 1, and that's correct. What's 1 divided by 3? Oscar's got it written down. It is 0.33333 repeating forever. Just put a little line on the top of it. Now, I don't want to write it that way, though, at least not in the line, because the one problem we start to run into, decimals suck, guys. And I don't mean they suck because like they're hard to write and work with, but when you start to get to the repeated decimals, they get overwhelming. So what I want you to do is to write it as the fraction that we just talked about. This is going to be 1 over 3. And then If I divide that by 3 again, it's actually 0.11111. The fraction for that one is 1/9. And I want you to look at our pattern for a minute here. 3 to the 0 is 1. 3 to the first is 3. 3 to the negative first is 1/3. 3 to the second is 9. 3 to the negative second is 1/9. What do you think this one's going to be right here if I wrote it as a fraction? 3 to the negative third. Based upon the way that this pattern looks, what would I have there? Greg, you are 100% correct. It is 1/27 because if you look here, 3 to the positive third is this 27. 3 to the negative third is 1 over that 27. So if I use that same idea, since I wrote an extra one over here, if I did 3 and I raised that to the negative fourth power, whoop, you guys can't even see that. What would that one be? 1 over what? What do you guys think? I know that 3 to the fourth over here is 81. 3 to the negative fourth is going to be 1 over. Oh, somebody type it and tell me. Yep, 1/81. You're absolutely right. So that's kind of the part that I want to make sure that we're understanding here. That really what you have when you're looking at exponents as they get larger, as they get smaller, as they're at a zero, you're creating a pattern that exists with a center, like with a center point of like, here's where everything breaks. And as the exponents, it's that zero. Raising something to the zero power is like the breaking point between everything. You got positive exponents this way, you got negative exponents this way. Anything to the zero power starts us off at 1. And here's the reason why I want you to think about it that way. Because what tends to happen with this is that people see a 0 and they always want to write the answer 0. But remember, when we're talking about exponents, we're talking about multiplication. If I multiply by 0, everything becomes 0. It doesn't grow, it doesn't shrink, it doesn't do anything like that. It just stays at a 0. So when I'm talking about the exponent 0, since I have to be able to multiply and I have to be able to divide, we start with a 1. Anything raised to the 0 power is that 1 because it's the center of our growth. Anything that has a positive exponent, these are multiplying, so we're writing with whole numbers. Anything that has a negative exponent, these are getting smaller because we're dividing. So we're talking about fractions, and those exponents are now going to be on the bottom, 3, 9, 27, 81. But if you notice, those ones are still there on the top because we're talking about 1 divided by 3, divided by 3 more, divided by 3 more. And in this case, it's 1 times 3 times 3 times 3. That's our center. And that's the place where everything starts from. So it's the reason why I want to make sure that you're seeing this with a pattern is that a lot of times people get messed up with this. Okay. They see a 0 exponent, they always go 0. The answer is 0. That's what I'm talking about. It's a 0. Nope. Remember, we're starting with 1 and either growing from that or dividing from that. And that's the way that we're looking. All right. How many of you guys are all right with what I just said? That what I just said makes some sense. You're like, all right, cool. If you're good, write a plus. If you're meh, write a minus. I'm going to say nobody's bad. If you're good, though, I want a plus. I want to see how many pluses I get. And if you're not, put a minus. I only got 2 people. Guys, I'm asking you to type one thing. Okay. So here's the part that I think is important to remember. Everything starts from 1 and either grows, either multiplies or divides. Everything starts from 1 and then either multiplies or divides, okay? So 1 is our 0. We're multiplying by a base. We are dividing by the base. That's kind of the way that this works. And that's kind of the reason why I've got these rules down here on the bottom here. If you look, b to the 0 power equals 1. So if I got a 0 exponent, it's 1. B to a positive exponent means it goes n times there. Now, they snuck in this little 1 over here on the side, 1 times a bunch of b's. And the only reason it's there is because if they say this is where we started our 0, that's fine. So if it's a positive exponent, it's got a lot of b's going up that way. It's a negative exponent, those just go on the bottom. So it's 1 divided by those things. So basically, the way that we want to look at it, God, this is written terribly. B to the 0 power equals 1. B to the negative anything is just the fraction 1 over that thing. And then we know b to the n is just equal to that many things that we have here. Those are our 2 kind of new rules here. Now, these things in the bottom here, they're fine. I don't know that it's going to be easy to help you, but like if I'm saying this, if I have a positive whole exponent, You have basically your 1 times repeat multiplication. If you got a 0 exponent, it becomes 1 no matter what. If you've got a negative whole exponent, so a negative number, it is 1 divided by repeat multiplication. So we call it a flipper because those just go on the bottom. So it's a term that I'm sort of stealing from Miss Smith. She's one of our algebra teachers as well. She calls them flippers because anytime you see a negative exponent, it flips to the bottom. And sometimes it's helpful to be able to look at that. Now we're about to get a little bit more practice with it, so I think you'll feel a little bit better. But that's kind of a good summary place for what we're going to be looking at here. Now, it's going to take us a minute, so let me kind of move this to the next page here. And I'm not entirely sure how many of these we're going to get to, but I do want to sort of move this to the world of what we do with an exponential function. So I want you to look here at that function right there. And I'm going to write it up at the top a little bit bigger because I think that we run into an issue when it's kind of buried in the problem here. So if I have f of x equals 20 times 2 to the x power, what makes it an exponential function is where the variable is. If I look right up there, if I've got a variable in my exponent, that is an exponential function. It means as that changes, what I'm changing is the number of times I'm raising this to the power. So I'm multiplying by 2 more and more times as I do this. Now, I want to make sure that you recognize how to evaluate these functions because you're going to be asked at different times to be able to kind of plug crap into these. And I want to make sure you know what it looks like. And if you look down here at the bottom, we've kind of got it sort of scaffolded out for you. So if I'm taking f of 2, that is my x. Now, if we look right up there, it should be up here in the exponents. I take that 2. I'm going to plug it in here for our 2. Now, if you notice, there's a whole lot of 2's here. F of 2, 20 times 2 raised to the 2. And, I would love to say that this was on purpose, but it's not. You do realize what the date is today, right? It's 2-2. You also know what day of the week it is. It's Tuesday. Guys, welcome to Tuesday. And that's what we're talking about here. And it's exercise 2. Guys, this is crazy. Welcome to Tuesday. I didn't even realize it was exercise 2 yesterday in the last class period. I'm just telling you guys, we're all about 2's here. I think if you play the lottery, you should go just straight 2's today. That's the way it goes. You're going to lose, but you should try it. All right. So now that's how we're plugging that in. And let me make sure we can see what it looks like for the other ones too. So if I'm doing f of 0, that means I'm plugging a 0 up here. If I'm doing f of negative 2, I'll have to write it out. It's still that 20 times 2 raised to the negative second power. So all I'm changing here is the exponent, okay? Now, so far, you guys okay with what I just did for the writing part of this? Everybody good? Okay, so here's where when we start to evaluate this, it gets a little bit sort of reviewy. Do you guys remember, our friend PEMDAS? You guys remember the order of operations? Because that's when this crap bites you in the ass, all right? When you're looking at this, you can't forget exponents come before multiplication. I'm going to tell you right now, the biggest mistake people are going to make here is they're going to go 20 times 2 is 40. 40 to the second power is going to be 160. I'm done. No. Exponents come before multiplication. So in every single one of these situations, this is the work I have to do first. I got to do that exponent. I got to do that exponent. I got to do this exponent. So let's do that work first when we write it. Can you guys tell me what is 2 raised to the second power equal to? What's 2 to the second power? Yep, 4. Absolutely correct. So our leftover problem here now, still multiplication there. It's 20 times 4. Now we'll get to that. Totally fine. That is our first step. You did a good job with that one. Can somebody tell me what is 2 raised to the 0 power equal to? One is correct. Anything raised to the 0 power is equal to 1. So 2 to the 0 power is 1. Still got our 20. So right there, we're good. Now let's see what we can do with this. Does anybody know if I do 2 raised to the negative second power, what's that going to be? 0.5? Close. That would be 2 to the negative 1 power. What would it be if it's 2 raised to the negative second power? Let's do a little work off here on the side and see if we can think about what this means. Remember, the negative power means we're going to have a fraction, right? So this is going to be 1 over 2 squared. We bring it down to the bottom like this. What would that 2 squared be on the bottom then? Yep, 4. So this will be 1 over 4. That's what my 2 to the negative second power is. So again, that 20 is still on the outside of this. It's still 20 times that, if I can write the 20. So 20 times a fourth is what we've got here. Now, let's do this in order of what I think is going to be probably the simplest. Here, f of 2 is 20 times 4. Can anybody tell me what the answer to that one is? 80. Yep. All right, cool. And then here, f of 0 is 20 times 1, which is, no, Marmar, it's all good. 20 times 1 is what? 20. Legit. Very good. Now, y'all, some people have trouble with the fractions. I'm going to tell you, I like what I call unit fractions because when I got a 1 over the top, all I'm doing is dividing. 20 times a fourth is the same as 20 divided by 4. Anybody tell me what 20 divided by 4 is? Yep, that's going to be 5. So this is what happens as we're changing this exponent. So when x increases by 2, what factor does y increase? Let's do this. Cross this out. Decreases, because that's the direction we went. When x decreases by 2, by what factor does y decrease? So we went from 80 to 20 to 5. What are we, by a factor, that means multiplying or dividing. What are we dividing by as we go in this direction? 80 to 20 divides by what? Yep, we are dividing by 4. So we look at this, it's divided by 4. We look at this, it's divided by 4. So that's kind of what we're going to be talking about here, is that as we're going in that direction, as that number gets smaller, we're dividing by a factor of 4. If it gets larger by 2, it's going to be multiplying by a factor of 4. And so that's kind of the idea as to what we're looking at, is that recognizing when we're changing the exponent, we're changing how many things you're multiplying by as we go through this. And if you went up by 1, it would be changing by a factor of 2. All right, I'm looking up here. It is 1219. That means I have talked about exponents for kind of a while, and we only got about 2 minutes left in class. So here's what I'm going to do. Right now, I'm going to stop this recording, and I'm going to stop giving you the new information. And then we're going to figure out, do you guys have any big questions that have nothing to do with this stuff? So stopping the recording.